Okay, hx is a product of fx and gx. Let's say this product function is continuous at x equals 0. So is it always true that fx and gx must be continuous at x equals 0? Okay, so let's see a counterexample. hx is 0. Right. So let's say hx is a constant function 0. So what is fx? Fx, it's a piecewise function. It is 0 when x is smaller or equal to 0. It is 1 when x is greater than 0. Right. So fx, right, it is 0 when x is smaller or equal to 0. Right. It is 1 when x is greater than 0. So what about gx? We can say gx it's 1 when x is smaller or equal to 0. 0 when x is greater than 0. So it's 1 when x is smaller or equal to 0. Right. 0 when x is greater than 0. So now if you multiply these two functions, fx times gx, right? So when x is smaller or equal to 0, it is 0 times 1. When x is smaller or equal to 0, right? When x is greater or equal to 0, it's 1 times 0. When x is strictly greater than 0. So it is just a constant function 0. Right? So you can see both functions. This fx is not continuous. It's not continuous at x0. Right? Gx is also not continuous when x is 0. Okay, but their product is continuous when x is 0. Okay. So let's do problem 8. Problem 8 is the Squeeze theorem. So first, what is f1? So for f1, you can just sub in x equals 1. Right, so f1 is smaller or equal to 3. It's greater or equal to 3, so it must be 3. Right. Second part, use the Squeeze theorem. So first, for the Squeeze theorem, we need two parts. First part, for this target function, we need to find its upper bound and lower bound function. Okay, in this question, it's already given. And second part, the limit of the upper bound and the limit of the lower bound, it should be the same. So here, the limit of this lower bound function, it is 3 times 1, it's 3. Right? The limit of this upper bound function, it's 1 cubed plus 2, right? It is also 3. So these two are the same, right? This is the second condition. Okay. So then what's your conclusion? The conclusion is the limit of your target function, when x is approaching 1, it is also 3. Okay. So this is a Squeeze theorem. Okay. So is fx continuous at 1? So fx is continuous at 1. It means, right, because the limit of fx when x is approaching 1 equals f1 equals 3, right? So by definition, fx is continuous at point 1. So fx is continuous at a point means what? Means fa equals the limit of fx when x is approaching a. So fx is continuous at point 1. All right, so now we can go back to problem 4J. Right. Problem 4J, this limit x to the power 4 cosine 1 over x. Right. So first you cannot split them because this part, the limit is not defined, so you cannot split them. So you can only use the Squeeze theorem. So how to use the Squeeze theorem? When you see cosine anything, it's smaller or equal to 1, greater or equal to -1. Right. So x to the power 4 times this cosine it's smaller or equal to x to the power 4 greater or equal to negative x to the power 4. Right, so this is the first condition for the squeeze theorem. The second condition, the limit of its left side is same as the limit of its right side. Right, is 0. So the second condition is also satisfied. Then what is your conclusion? The conclusion is that the limit of the function in between, it is also 0. Okay, so this is a squeeze theorem.